Hey guys, hope you guys are all doing well. We all miss you at Ursuline a lot. Hopefully we get back to school soon. What we're going to do today is a little bit different than most of our audios, which you're done for the year, unless, again, we have to kind of regroup for those final chapters before the cat dissection. We're going to do an EKG lab today. I wish you guys were the ones doing it, because this is one of my favorite things, and I know students love it because you get to see your actual heart rate and each of the waves that I talked about on the audio, and then also on your packet. So go ahead and pull out your packet right now, because I really do want you to understand what's going on in an EKG, not only so that the next time you see it on Grey's or House or any of those shows, but that for the future, when you're in the hospital and you're giving birth, they're going to monitor the electrical activity in your heart, and if there's any issue, possibly in the baby's heart as well. And so you can tell a lot from an EKG. And again, you're going to see my electrical reading and my daughter's as well, just so that you can compare both of them. An EKG is an electrical reading in the heart, and it's reflecting what's going on in the atria and the ventricles. You can tell anything from angina to a myocardial infarction to an arrhythmia. So a common condition is long QT syndrome, that you can measure the interval in between waves, and if anything is off, you know that something's wrong. This lab over the years, I remember 13, 14 years ago, one of my first students, she was the biggest hypochondriac. I've made mention of her in a few classes this year. She was the one person of anybody in 14 years that I would not have wanted to have an abnormal EKG. And of course, that's exactly what happened. We hooked her up to 4 or 5 different machines to make sure that it wasn't operational error. And it wasn't, and she went and they actually monitored her throughout the rest of the year and into college, and it was kind of a running joke, from that point forward. There's been several over the years that have looked a little wonky. A girl 2 or 3 years ago, her mom actually worked for the American Heart Association. She took a snapshot of her EKG, sent it to mom, and mom immediately brought her in. And again, it was something minor, not life-threatening, but it is something that I don't want you to walk away with the idea that, yes, it's an electrical reading and everyone's EKG is mostly going to be the same because we have the same atria and ventricles and corresponding blood vessels, but there are minor differences, and that's what we're looking for in these. Like, why would the QRS wave be higher in one person than another? How does that reflect the strength of the different chambers of the heart, specifically the left ventricle? And so the first thing that I want you to notice, I'm going to put my arm up here. I do have 2 electrode patches on my arm, on my right arm that is, and then one on my left arm. The one thing in the lab that we're not going to do is you switch the leads to see how that affects the EKG. It would actually invert the waves because you're reading it backwards in essence. Remember, the pacemaker is in the right side of the heart. We'll go through that I'm going to do it a little bit differently. I want to walk through blood flow because it is such a huge component of your future tests. That won't be for a while, it won't be next week. But some of you asked in the survey to actually see, like I would do in class, to actually see things in action, since you can't have lab materials at home. And I don't want to send you out to a store to, get a special needle to suture. We're going to do the best we can to kind of bring it to you at home, but I am going to walk through blood flow. And remember, that right side of the heart is where we are going to initiate that wave that's going to spread across not only the heart, but then pump it out to the blood. With that being said, that's why we have them on the right side first, because that electricity starts on the right-hand side. You want to read the corresponding nerves. We're taking neural activity here on the right side of the body, and then it'll go to the left, and that will give you an EKG reading. You're also going to be able to analyze heart rate. I'm going to show you on Vernier everything you need to do, and so you will want to have your lab pages. It's more of a completion grade. You'll get a normal lab grade, but I do want you to track with me, and then I'll also help you with the questions after, which are not writing. All you're doing is analyzing EKGs that the lab has given to you. I remember my first year in Dallas, we lived in Uptown, and we would walk over to this ER doctor's, or he might have been in cardiology. He was a resident at Parkland, and all over his house he had taped up little EKG readings, like hundreds of them, and he would kind of walk me through. All the patient names were blanked out, and he would walk through like the nuances of an EKG, things that you would have to be trained to recognize, and what each of those nuances would reflect. And so they do tell a lot. You're going to see a reading. You've heard me talk about it on the audio. You've done it in the packet, but I want you to see it live, see the actual rhythm live, and then we'll walk through what that all means. Okay, so here we are in our Vernier Logger Pro specific file, analyzing the heart with an EKG, and I've connected the leads to each appropriate electrode sticky, and again we're going to take the electrical reading of the nerves in my arm that reflects how the heart is beating. So here we go. Press collect. Okay, so go ahead and take out the page in your lab that I put on Blackboard and OneNote that I sent to you, and it's got a chart in it, and it has the PR interval, QRS complex, and QT interval. And what we're going to do is fill that in for me, and I've got my little cursor here. So the first thing you notice, I'm going to walk through this again because I'll just flat out tell you we're in different times. This is going to be an essay question, a future essay question, because I want you to be able to take things away from this class that 100% you are going to use yourself. Again, whether you ever take another science class or not. So the first thing we want to do, I got a little interference in here. It's pretty consistent, but either way, we can definitely see the P, QRS, and T waves. And again, let's see how this is different than my daughter, who I'll put the electrodes on in a second. So let's start with this one. This right here is going to be the P wave. Remember, the P corresponds to the atria depolarizing or contracting, something that you would want to know probably twice over for the test. So the P wave right here, the atria are depolarizing or contracting. The Q is right here. The R is the easiest to identify all the way down to the S. The QRS wave, two things are happening. Number one, the atria are repolarizing. Remember the heartbeat initiated by our pacemaker is going to go from superior to inferior, kind of diagonally down the heart. And so the QRS wave is going to stop here, and the ventricles are depolarizing. So the ventricles are now contracting, the atria are relaxing, or another way you could say that is the atria are repolarizing and the ventricles are depolarizing. Yeah, my T wave, I don't know why it's hitched here. Maybe I'm dying. Maybe I have the virus, hopefully not. The T wave right here is going to be the pinnacle of where the ventricles are repolarizing or relaxing. And then you go into this, this calm period. So this is the time from the bottom of the T down here, the time that it takes for another heartbeat to be initiated. So this is when your heart is doing nothing at all and blood is going to be refilling the atria to be pumped out. And then this right here would be the start of another P wave. So we're going to go ahead, if you look at the example that they give you, we want to figure out how much time it took for each of my waves. And then we're going to do a little bit of math to figure out what my heart rate is, which I can already tell you is a little bit high. Maybe I'm nervous about doing a virtual lab, or with everything going on in the world. I don't know. Okay, so what we're going to do is highlight beginning of P wave all the way to where the R wave is right there. If you look at the bottom down here, the delta T is right here, is going to be 0.07 seconds. So you want to go ahead in the time slot, time in seconds is 0.07 seconds. Remember, this is fractions of a second. And if you have an arrhythmia, or it's too long of a heartbeat, blood will backpool. And since it's a giant pump, you need blood, to go from the left atrium to the left ventricle to the aorta and to the body. And then, back to the heart through the superior and inferior vena cavas. You need it to be flowing properly, especially not just at rest. Oftentimes people find out that they have an issue during strenuous exercise. Okay, the next thing that we are going to do is my PR. Here, let's do this again. I'm going to do it over here because this one is a little bit easier to see. So go ahead and erase that. This is a little bit better, 0.11 seconds. So mine is, pretty short overall, I would say. Then the QRS interval, we start at the Q and then we go to the bottom of the S. The time, this is the most important one because it's the most violent contraction of getting blood out of the heart to the rest of the body. And so you really do want this to be less than 0.12 seconds. You notice at the bottom for the QRS wave, you can enter 0.09 seconds. And then the Q to T interval, again, we're going to highlight here the Q all the way to the bottom of the T, and it's going to be 0.37 seconds, which again, the Q to T interval, if you notice table 2 at the bottom, is going to be between 0.30 and 0.40 seconds. So everything fits. That P to R interval is a little bit condensed. The P wave should be, there should be a little bit of lag time in between the P and the QRS. But overall, when you look at that, I can tell you people in the past have oh my gosh, I'm 0.1 seconds off. Listen, if you've spent 18 years and you're normal, we have physiological and anatomical differences. The two are connected. And so it's okay. It doesn't mean that you have an abnormality in your heart. It means that your heart, it might work slightly differently, but it's not something to be concerned about. I can tell you those people that I mentioned before, their waves are all over the place. Their S wave is way down here. Their T wave, you can't even see it repolarizing. Sometimes there's so much interference in their nerves that you can't even tell what's going on. But the main thing that you want to see or avoid is an arrhythmia. This looks pretty consistent, right? Like the time in between R waves. And so, overall, I think it's okay. And again, we're going to compare my daughters in a second. Okay. One way that you can do to find out the heart rate. Oh, sorry. We need to do R to R. And R to R looks like it is 0.83 seconds. And so really there's not necessarily a desired range. You don't want to have tachycardia, which I mentioned in one of the audios, above 100 at resting. I can tell you from looking at this that it's not going to be above 100 at rest, although it is a little bit high. And the way that I can tell, some people want to eyeball it. They just want to say, okay, how many R waves are there in in each reading. And you notice that this is 3 seconds at the bottom. So they'll count the R waves, 1, 2, 3, 4, easy enough. And then multiply the 3 seconds into 60. So we have 20 of these intervals would fit into 60 seconds. So you'd say 20 times the 4 R waves, because those are the easiest ones, to identify on an EKG reading. So 20 times 4 is 80 beats per minute. The problem with that, just like the caffeine lab, if you did it for extra credit earlier, is that you get fractions of a heartbeat, because the difference between 3 and 4 or 4 and 5 heartbeats multiplied out over 20 times this interval is a lot. You could get 10, 15 extra beats if another R is right about to start here, but we don't count it. That's a significant difference. So the more accurate way to do it, and I don't have a calculator handy, but I'll be able to tell if you did this, do 60 divided by your R to R number. And it doesn't matter if we used R to R, we could do the top of the P wave to the top of the next P wave, because that is one entire heartbeat. Another question on the test, which I think I have labeled in my packet that I'm going to post this week, R to R is an entire heartbeat, but you could start anywhere you want. You could do top of T to top of T, beginning of P to beginning of P, whatever you want, because it encompasses everything then. So beginning of P to the next P would have a QRS wave, a T wave, the relaxation period, all the way to the beginning of the next P. I think it's easiest to do R to R. So again, my heart rate is going to be 60 over 0.83 seconds, and go ahead and enter that heart rate. Okay, this is our second test subject, my daughter Harper.
Hi, I hope you guys are doing well at home.
Okay, so we're going to take her EKG now. Okay, so we are going to go ahead and take Harper's EKG, and then I will point out some of the differences after in the reading. Okay, so at first glance, you probably notice a few things. Number one, the QRS wave is not as pronounced, standard for a younger person, and I want you to think about the why behind it. The QRS, if you remember, reflects the ventricles contracting, and the ventricles contracting are going to be forcing blood out to the entire body. She's a smaller person than me. She hasn't done as much athletic activity, played sports for as long. And so this is representative of a younger person, that the peak is not going to be as high and as dramatic, because her heart does not need to be as strong, number one, because of her relative size. And number two, it's just naturally that muscle grows. Remember, cardiac tissue is a muscle, and with that, it will physically grow because of the strength of contraction. So if we opened each of us up, it would, your heart size, outside of having a condition that would cause your heart to atrophy, hyperatrophy, would be reflective of how much blood and how forceful does it need to pump. So what you do to stay in shape, or athletic activity. Okay, so you see that the QRS is not as pronounced. Yeah, you can see her P wave. There's a little bit more of a lag time than what was in mine. It doesn't look like long QT syndrome. This would fit within the normal range. And then you see a shorter relaxation period. One old wives' tale that they'll tell you, and it is somewhat reflective too when you're having a baby, is the higher the heart rate, the more likely it is for you to have a female. It is a myth, so I don't want you to go with that. But some people swear, and some doctors will even say, if it's in the 180 to 200 range at that 6 to 10 week mark, that it's likely to be a female, and that male's heart rate is a little bit slower, and that holds true, throughout time. So a typical heart rate for a male, depending on age, is going to be anywhere from 70 to 80. And then for a female your age, it'd be somewhere in the low to mid 80s. For Harper, again, if we multiplied this out, you could do it, her R to R, and I already see 5 R waves here. So you see that it is 0.57 seconds. So it is going to be 60 over that number would be, I guess just under 100 beats per minute, which again is, is standard for somebody her age as the tissue begins or continues to develop. Okay, now we are going to flip over to, not me. Okay, go ahead and go to this page in what I sent to you. And I'm gonna help you. A is given to you on the back page. Don't worry about number 1. I already told you the answer to that. So letter B, the difference between the interval, which is time, and the shape is, you wanna see, did it take too long? Did it not take enough time? So let's see here. A T wave or a P wave. We'll go through this one just because it's easiest. You notice that the P wave, I would say that the shape is okay. So mark that in the box. The shape for the P wave is going to be okay. And then the PR interval, which again is P to R, I would say that is okay as well, normal, ML. But the QRS interval, I think, there's not that much time, but err on the side of normal, unless it's completely abnormal. So the interval, I would say, is normal, but notice the S doesn't come all the way down here. And so I would say that the QRS shape is off. And then the T wave, for this one, the T wave shape, I think that's perfectly fine. But then you notice over here that there's kind of a hitch in the middle of it. So this T shape would be off. The problem with, so this P right here, I would say that the shape is going to be, the P wave is off, because look at it relative to the first P wave. So you're gonna keep going through each P, the shape is off. The P to R interval, I would say, is fine. The QRS interval, very similar to the first one. The interval is fine, but the shape is off. And then the T wave is off. The next one, notice that the P wave is completely missing. So I would put that as absent. Same thing with QRS as the other ones. And then the T wave is more normal again. And then this last one, the P is back to being normal. So this would be the same as this one right here. What you really don't want to see, you can see it in this one, you can see it in this one. This one, these are off, but you eliminate the possibility of an arrhythmia, which is an irregular heartbeat. You see inconsistency between the interval between R to R. Even in Harper and my EKGs, well, not perfectly clean, and there were some things in the middle, which is picking up other electrical activity. You see that for the most part, the time in between R to R is fractions of a second, which is what you want. And so when you get inconsistency here, it means that the heart is not pumping equally, like missing a P wave altogether. That's not good, because your atria are not contracting. The ventricles are going to take whatever blood has leaked between the bicuspid and the tricuspid valves into the ventricles and pump those out. And so you really want consistency, even if it's a little bit faster or slower or whatever it is. Okay, so go ahead and fill out C, D, E, F, and then on the next page, G and H. Only fill out in the chart, if there are only 2 waves, then that's all you need to fill out. You should know by now, labs, don't worry about like, oh, you don't need to email me or remind our teams like, oh, is this one this or that? I want you to try and figure it out with a guarantee that you lose absolutely no points if you do your best to figure them out. Some of these are completely subjective and I wouldn't have an answer to it, and that's why people go to years of training to be a cardiologist and learn how to read an EKG or an echocardiogram, which I might put something online to kind of highlight the differences between them. The echocardiogram is a form of a sonogram with the gels and to look at the actual heart chambers and more importantly the valves to see what's going on. Okay, so this concludes the EKG. Go ahead and you can send me the page with my numbers on it just as kind of a completion thing, and then these the very back page which will allow me to see your analysis of the EKGs given.